Okay, as promised, we would get to a real drawing. And this is a real drawing. Now, first thing we're going to look at, and the purpose of this video is to get us familiar with looking at the different components that make up a drawing. It's more than just the part views and the dimensions and tolerances. Now, as we look at this drawing, the object, which you can see, only makes up part of the drawing. There's a lot more going on here for such a simple part, right? Here's the object views. This object should look familiar. It is our block, which was essentially a flat plate with a hole in the center. And there's some things on here that will not look familiar, at least not from the videos that we've done so far. So I am going to cross out a couple of those. And that's these items here. Now, I wanted to get you to a real drawing, but we have yet to cover what is known as GD&T, or geometric dimensioning and tolerancing. So the things I'm crossing out in red, I want you to ignore. As for the rest of it, it should all, what's in the field of the drawing here should all look familiar. We've got our 4-inch block, right? And it's 4 inches by 4 inches. And we've got our 3/4 of an inch hole with the 2/1000 tolerance that we talked about in the tolerancing video. It's 1 inch thick. We've tightened the tolerance up. It's if you remember from the previous video, it was plus or minus 10/1000ths. It's now plus or minus 1/1000th of an inch. Okay. But otherwise, this drawing essentially looks the same as this object we used in the previous video. You will, however, note that the drawing contains some other information here. For starters, there's a border right around the field of the drawing. We've got some notes down here, right? And we've got something here called a title block. Down here. And then we've got something up here. This is called a revision block. And then we've got, and you won't always see this, but usually you will, we've got some letters going vertically up each side of the drawing border, right? And then we've got numbers going across. Okay. And what these are, it's like Battleship, right? The old game Battleship. If I wanted to describe an object on the telephone, if I was talking to an engineer, or if I was writing an email and I had a question about a certain part of the drawing, particularly on a large drawing, let's say I had a question about this letter C in the box with the red X through it, right? To quickly communicate where on the drawing I was talking about, I could refer to this, what we call a zone, right? And I'm going to draw a line across here. So I could call up and say, hey, Mr. Engineer, there's a, in zone D4, right, D4 of your drawing, there's a box with a letter C and a red X through it. What the heck's going on? And he could say, well, I heard that you haven't learned about GD&T yet, so I took it off of the drawing, or whatever. So that's what these letters are going around the outside. So we've got a notes section, we've got a title block, we've got a revision block, and we have a border that may have grid indicators on it so that we can easily communicate locations of the drawing. Now we're going to first look at the title block. And see what's going on in the title block. Well, first of all, here's the name of the company and the logo. You usually see that stuff, right? Then we've got a title. Imagine that, a title in our title block. And the title here, this is not a title block, but this is the title of the part, or the name of the part in this case, is a block. I guess we could have named it something more original. Then we've got here this letter B, and that just refers to the original size of the drawing. This is becoming less important these days, but if you were, imagine that you were in a reproduction department, and you were responsible for making copies of drawings, right? It would be pretty helpful if when you pulled the drawing out, you could look in the title block and see, okay, what size paper do I need to copy this onto when you're dealing with multiple sizes of drawings. In the ANSI system of drawing sizes, ANSI, which is the American National Standards, I'm abbreviating here, Institute. Right, and the ANSI standard drawing sizes are A, B, C, D, E, J size. I don't know if there's an F size in there or not. Each of those has a standard size. So an A size is your standard 8.5 by 11 sheet or 11 or letter size paper. B size in this case is your 11 by 17 or what's known as ledger paper, and the sizes go on up, and that's all that means. And if they're ISO or DIN, they'll have a different letters. They have A1 and etc. And that just tells you the size paper that the original drawing, as it was drawn, was intended to be printed on. Over here, we have the scale. Okay, and that just tells us again at the original size the drawing was intended to be printed, what scale it was, and this is telling us that our drawing is 1:1. Now, that could be written as a fraction. Often it will be, like 1/1. And if the scale was half scale, for example, or 1 inch equals 2 inches, 1:2. What that would mean is, I'm sorry, got that backwards, 2 inches. That was correct. 1:2, which is the same as 1 equals 2. It's getting late. That would mean that 1 inch on the drawing equals 2 inches in real life, which would be the same as half scale. Then there'll be often a release date. That may be somewhere else, but in this drawing format it's here. There's the weight of the part, and again, that's optional information. It may not be on all title blocks. And then over here is the sheet number. In this case, it's a single sheet drawing. We're only dealing with one total sheet, right? But it could be, if let's say that there was 3 sheets to this drawing, then you would have like one of 3. Sorry. 2 of 3 would be the next sheet, separate sheet, and then 3 of 3, right, would be the last sheet. So that's what this block is for. So in this case, with this one sheet of paper in your hand, I have the entire drawing. Whereas if you had sheet 3 of 3, and that's all you had, you would look at it and say, there's 2 more sheets to this drawing. And we have something called the revision, and that just means each time the drawing is revised, the drafter will increase this letter, and it starts with a dash, and then when he makes a revision to the drawing, say he adds another hole to the drawing, that becomes revision A, and then we go to revision B, C, and so on. Right? Now, some companies use different formats. Letters are most common. Some may use numbers. Sometimes the first rev is not a dash. Sometimes it'll say original or IR for initial release. The conventions vary by companies, but rev dash is common for an initial release, and then rev A would be next, B, C, D, etc. Next piece of information is often, not always, something called a cage code. Okay, and the cage code is also known as an FSCM. Right, and I'm going to change colors because we got too much purple here. An FSCM just means it's a federal supply code for manufacturers, and that's just a identification number that the government uses. So you register your company with the government and the U.S. government, and it's a unique identifier for each company. And so when that number is in the title block, it tells you who has the design authority for this product that's represented on the drawing, and using their federally issued identification number. Now, not all companies have those, but anybody who does business with the government will have one, certainly any defense contractors. Then we have a drawing number, and that's just a unique number for this document. Oftentimes the part number of the part on the drawing will match this, or it will be, this drawing number with a dash number appended to it or something like that, but not always. What this number represents is the unique document number that identifies this document. Then we've got whoever was the designer when he approved this drawing, and the approver, which may be his boss. Depending on the complexity of the organization and the approval process, there may be many signatures here, or many sign-offs. In aircraft design, there may be a stress analysis person, a weights person, a whole list of departments that would have to sign off on a drawing. And nowadays, because many times these sign-offs are done in a database somewhere, it may just say signature on file or something to that effect. And the last piece of information that we want to talk about that's very important is the tolerance block.